Welcome to the video demonstration of Big Cloud Fabric Container Networking Solution for Red Hat OpenShift Container Platform. Before going into the demo, let me give a quick overview of the solution. For this demonstration, I will be using Big Cloud Fabric P+V physical and virtual solution with BCF container networking plugin for Red Hat OpenShift Container Platform, which automates container networking and provides advanced visibility into container networking. Big Cloud Fabric P+V physical and virtual provides single pane of glass for both physical and virtual networking, which simplifies the container networking operations. In this demo, I'll be walking you through following aspect of the solution. First, how BCF automates provisioning of Red Hat OpenShift cluster nodes to the network to provide single pane of glass for both physical and virtual networking. Second, containerized application deployment using OpenShift Container Platform with Big Cloud Fabric Container plugin to provide container network automation. Finally, BCF visibility features, test path and fabric analytics, which makes monitoring and troubleshooting of Red Hat OpenShift container networking easier and simpler. This is the Dcf Controller Web Interface, which is a single pane of glass for managing entire physical and virtual fabric. BCF Fabric Page provides the BCF topology. For this demo, we are using 3-rack BCF topology with 3 Red Hat OpenShift cluster nodes, which are connected to this Big Cloud Fabric. Bottom of the Fabric page shows all 3 Red Hat OpenShift nodes, which has BCF virtual switch installed. These OpenShift cluster nodes are auto-discovered and managed by BCF controller for networking. If you mouse over the switches, it provides the switch name and connection details: OpenShift master node, node 1 and node 2. If you click on the switch, it provides additional details for that switch on the left. BCF also forms link aggregation to all the nodes dynamically. This can be seen on the BCF interface group page. As you see, cluster has 1 OpenStack master node and 2 agent nodes. All are auto-discovered and link aggregation is formed to those nodes dynamically, as you can make out from mode and auto-discovered column. If you click on each of these nodes, it provides a physical link connected to these nodes used for link aggregation. This is one of the key benefits of BCF solution, where all Red Hat OpenShift cluster nodes are auto-discovered and link aggregation is formed dynamically as you connect Red Hat OpenShift cluster nodes to BCF. No manual config required to provision the Red Hat OpenShift nodes onto physical fabric. Now let's look at the Red Hat OpenShift Container Platform Web Interface. Logging in as Project Red Admin. Project Overview page lists all currently deployed applications. Project Red has 2 applications deployed, Redis Master and Hello OpenStack app with the 2 instances each. The way BCF plugin works is, as you deploy the containerized application using Red Hat OpenShift Container Platform, BCF plugin provides unique IP address to the container based on the network segment configured for that application. Then it attaches the container to the BCF virtual switch on agent nodes. And then BCF agent takes care of configuring BCF controller with relevant segment membership configuration for the newly deployed application containers. From network admin perspective, he or she would have full visibility into the container, and admin can continue to use current network operational best practices for container networking as well. Now looking at the BCF Endpoint Page, which provides the details about currently deployed application containers, which are dynamically learned and configured through BCF Red Hat OpenShift integration. This includes applications tenant and segment, container name and description, container IP and MAC, virtual switch or agent node where containers are hosted, and virtual NIC of the container. Now let's scale up the application instances and look at how BCF dynamically takes care of networking for the newly spawned containers. Now scale up Hello OpenShift application to 25 instances. Similarly, scale up Redis Master to 10. At this point, Red Hat OpenShift will spawn additional application containers to reflect new application pod numbers, and BCF plugin will take care of networking for these newly spawned containers. Now BCF controller would have details about all new application containers. As you see from BCF endpoint table, these are dynamically learned and programmed through BCF OpenShift integration. Now let's scale down application back to 2. As you see, BCF plugin has updated the configuration and only 2 container instances of each application are seen on BCF endpoint table. As you saw, BCF integration takes care of fabric config automation for container networking as you deploy, scale up or scale down your application using Red Hat OpenShift. Now with application containers deployed, let's look at the BCF monitoring and troubleshooting tools for Red Hat OpenShift container networking. BCF provides test path feature, which can be used for connectivity test between 2 container endpoints from BCF controller with a couple of clicks. and no box-by-box troubleshooting required. Let me run connectivity test between two OpenShift application containers, provide source container and destination container for the test, and provide application flow info. Once you run the test, BCF Controller View provides connectivity test result for the given flow between the two containers. This provides logical and physical path for the given flow. And BCF Fabric View provides even more detailed physical path in the fabric for the given flow between containers, which includes source virtual switch, physical leaf, spine switches, destination virtual switches with ingress and egress interface details at each hop. For example, source container is hosted on OpenShift node 2 and shows the ingress virtual NIC and uplink used on the OpenShift node 2, which is ENP8S0F1. Similarly, at each hop, you would see ingress and egress interface for the given flow between container endpoints. Now let's look at the BCF Fabric Analytics for monitoring and troubleshooting BCF Red Hat OpenShift container networking. BCF Analytics provides the historic report of all BCF networking events and statistics. This includes container networking as well. BCF Fabric Analytics provides customized analytics dashboard for container networking. If you click on Container Dashboard, this provides all container networking events. You can zoom into time window to get events specific to that time window. You can click on individual events to get more detailed info on that particular event. To summarize, BigCloud Fabric simplifies the Red Hat OpenShift container networking solution, which is easy to deploy, manage, and provides network administrators seamless container networking automation and a consistent view of their entire networking environment. Thanks for watching.